Okay, let's get started. Okay, so here we are, 3 weeks of the semester left. You've got the assignment due today, or tomorrow, is a late day. And then it's just the final project and the final exam coming up. One thing that hasn't received much attention yet is PS 11A, which is picking your team for the final project. Out of 300 students, let's say, in the class, I've got 218 left that haven't picked a partner. So you've either, if you're working alone, you need to do something. If you're working with a partner, you need to do something. But you need to do it by Wednesday. Yeah?
Only one of the two partners needs to...
Only one of the two partners, yeah. So you need to pick a team name, and if it's just you, only one of the team, you go to PS 11A and do the registration, or if there's two, do the registration. We really want you to work together. It's a good experience, it'll be more fun, and it's less grading for us to do. So we get all around. So please take care of that. And if you're looking for a partner, come up here at the break or after class, and maybe other people looking for a partner. There's the lab tomorrow, be a good place to try to find a partner or whatever. But do be giving that some attention. Are there any questions or problems about anything? Yeah.
When you want to test a new game, it's kind of difficult because you have to do like random it's all random.
Okay. So what she's asking about is PS10, you're writing test cases for the model. You know, the method that creates a new game in the model, assume you have one. You're supposed to create a game that's solvable, which makes it kind of hard to test because you have to implement code that knows how to solve the game. So yeah, in that case, it's kind of tough to test, so we understand that. Yeah?
In terms of testing it, are you going to be looking for like a certain amount of tests, or just that we tested it to begin with?
Well, the biggest part of it is that you write some, you know, that you are making an effort to test your model. The method that creates a new game, you know, the more the better. Yeah?
Are the test cases going to be weighted really heavily on this assignment like they are on previous assignments?
I don't think so. So he's asking about how heavily they'd be weighted in the grading. I don't think they'd be very heavily weighted. Yeah?
To test, could we create a method that just clears the board and just sees that, ignoring the functionality of, like, say, like a one method, like a half one method?
Well, okay, so the general idea is you're going to have a model class that provides what what the game needs in order to function, and so whatever methods that provides is what you want to test. I wouldn't be adding new methods. It just makes more methods to test. I had a student ask me today, did he need to test for that the model threw exceptions? And my answer was, what do you think my answer was? I got some of this, but any of this? Yeah?
It shouldn't be throwing any exceptions because all the input, you can predict all the inputs. So.
Okay, so he's saying it shouldn't throw any exceptions because the GUI won't make any bad calls. But you're testing it independently of the GUI, right? The idea is the view is just off there. The view is really hard to test, so we won't worry about that. It's the model we're talking about. And you can use the model independently of the view, right? So you need to test exceptions. Well, when you test something, what are you testing against? I mean, how do you decide what your test cases ought to be? Yeah?
So you could just create an array of all zeros, or however you decide to implement your board, and then just create like a new, or create like a new board, and
okay, well,
make sure it's equal to
so he's describing how he might construct a test. But how can you tell whether your test case is right or wrong? Right? You write some tests, you make some assertions about the behavior of constructors and methods. How do you decide what assertions to make? Yeah?
Well, in your Java docs, you should specify specify exactly what should happen in what cases, so you should just assert that the behavior matches your documentation.
Right. It depends on the Java doc. So if your Java doc for a method says, this method throws an exception when row or column is less than 0, okay, that's in your specification. You should test it. If, on the other hand, your specification says row and column are required to be non-negative, and goes on to say what to do when they are non-negative, then you're not claiming any particular behavior when row or column is less than 0, so there's no need to test that case, because you're saying that that case isn't allowed. So it just depends on how you specify things. You test to your specs. The more detailed your specs, that's good, but it also means the more detailed your tests need to be. Any other questions? Okay. All right, here's where we were last time. We're studying ways in which polymorphism is used in this little paint program that we're constructing. And this is version 3 right here. And just to remind you how it behaves, if we run it, it brings up a little GUI like that, and we can pick a shape, and we can pick a color, and we can click. I'm running the wrong version here, so sorry about that. Try again. Okay, so when like I pick rectangle and I pick blue and I click, and it just plops down a rectangle of a given size. So all I got control over is the center of the rectangle, the center of the circle, the end point of the line. And we'll gradually make this behave more like a real paint program. But our goal, painting is nice, but our real goal is to look at polymorphism. So let's, paint panel is the class that keeps changing. That's the panel where the drawing is occurring. Let's just go through here and remember from 5 days ago all the places where polymorphism is used. Remember polymorphism, we've looked at 3 forms of polymorphism. There are generic data types, such as array lists and sets. There's inheritance and there's interfaces. So what do you see when you look at this thing? What examples of polymorphism do you see? How is it being used here? Yeah?
There's an interface with mouse listener and mouse motion listener.
Okay, so we have paint panel implements 2 interfaces. So remember, polymorphism means roughly many forms, something that can take multiple forms. And by saying a paint panel implements mouse listener and implements mouse motion listener, that means that a single paint panel object can be used in one context as a paint panel. It can be used somewhere else as a mouse listener. It can be treated somewhere else as a mouse motion listener. So the same thing is taking multiple forms depending on what you need. Okay? Someone else tell me, what's another example here where we're exploiting polymorphism? Yeah?
It extends Jpanel.
Okay. It extends Jpanel. So it is saying a paint panel is a Jpanel with some differences. And what you put in the class are the differences. If you're happy, if you're happy inheriting a certain behavior, you don't need to say anything about it. You just get it for free. Now let's try to think why. Why do we want to say that a paint panel is a Jpanel? What do we get out of saying this thing is a Jpanel? Yeah?
We could put it into a JFrame.
Okay, you can stick it into a J-frame or into another Jpanel. So it lets us create a custom thing, a custom component that we can embed into somewhere else in the GUI. If we didn't do that, if we didn't say extends Jpanel, then we couldn't use it in the GUI. It wouldn't do us any good. Okay? And why are we implementing these listeners here? Why do we want to say implements mouse listener, implements mouse motion listener? Yeah?
Because we want to be able to pass a paint panel into any method that requires a mouse listener or mouse motion listener object.
Okay, so we're going to listen for those certain mouse events as the program is running, and we've got to have an object that can be notified when an event happens. And I've chosen just to use the paint panel object itself as a listener. There are other strategies that could be used, but that's the simplest. Yeah?
Is it correct then to say that an interface is an abstract class?
Well, he's asking, is it correct to say an interface is an abstract class? Haven't really talked about abstract classes too much yet. We'll later. No, they're not. It's not correct that they're the same. They're similar. And we can talk about ways they're similar later. Right? So there's a couple examples. Where else do you see examples of polymorphism at work? I don't have to scroll very far. Yeah?
No, Renus.
Okay. So right here. This is the generic types. So array list, we're saying we want an array list of oval. Here we want an array list of rectangle. Here we want an array list of line. So we're taking one thing, array list, and it's taking different forms depending on exactly what we need. Okay? In the old days, before there were such things as inheritance and interfaces and such, if we wanted something that was just like a Jpanel, but had some differences, what do you suppose you had to do? You had some class, some collection of code, and you wanted something like it. Yeah.
You have to copy paste all the code and then change it.
Right. You would take the code for Jpanel in this case, copy it somewhere else, change the class name to Paint Panel, and then edit it. Okay. So you might wonder where these ideas in programming languages come from. They come because lots of programmers do the same thing, and it looks like it'd be the same thing in this case, being editing existing classes and making small changes to them. And it occurs to people that it'd be simpler if the language provided that support, so that rather than having to physically edit existing classes, you just could say, okay, here's this thing is a Jpanel with the following changes. Okay, so let's see, we're keeping track of all the ovals, rectangles, and lines that are on our paint panel. These come in via the constructor. They're just the places we go to see what shape to draw and what color to draw. So, those are groups of radio buttons. Here's our constructor, which just creates empty lists, sets a background color. What's going on there? Okay.
It's basically acting as its own mouse listener and mouse function listener.
Okay. That's where we register this as the mouse listener and this as the mouse motion listener. So someone else tell me, what is this in this case? What does this refer to?
The object on which the method was invoked.
Okay, it would be the object on which the method was invoked, except in this case it's a constructor. So it's the object on which the constructor was invoked. So see, somewhere, when this runs, someone said new paint panel. And so the paint panel object is created, the constructor runs, and it registers itself. The object being constructed is registered as the event listener with these two kinds of events. Okay? If we wanted to be pedantic about it, we could say, okay, this.ovals. Referring to the ovals instance variable of the object being constructed. So we could spell it out like that, but this always refers to the object on which the method was invoked or the object that's being constructed. All right? Let's see. Now, where are we using polymorphism here? Yep.
On the super part, are you calling the Jpanel?
Okay, well, there are a couple things going on. First, let's talk about this. What's happening there? Yeah.
Well, the at override recognizes you have a method of that same name in a superclass, and by putting that at override there, you're saying, I want this method to be called when this method name is used instead of what's there.
Okay. So we're just saying, okay, because we extended Jpanel, we have a paint component method. What we're saying here is replace that paint component method with this one. Throw out the old version and put in the new version. So that whenever paint component is called on a paint panel object, this method will be called instead of the original one. So this is if you want to have something that has a custom way of drawing itself inside of a GUI, this is how you do it. You replace the paint component method with a different one. So you really couldn't, that's just that's how a Jpanel is designed. It's designed with a bunch of methods. It contains a bunch of methods that are designed to be replaced. To customize behavior. So we're customizing what happens when this is called. So when someone calls paint component, all right, what's happening there? What is super.paint component? Yeah.
Superclass has a paint component method, and you want to just directly use it. You're just using super.paint.
Right. So super.paint component refers to the paint component, the original paint component method that we're replacing here. So from the outside, if someone just has a paint panel object, they can't call that original paint component object, paint component method. They can only call the new one. But internally, we're allowed, we have some privileges internally, we can call the one that we just replaced. Yeah?
So even if they use super.paint component in another method, you can't?
No, just like you can only use super inside of a class that extends something. Right? Just the same way you can only use this inside of a non-static method or a constructor. So you couldn't say super. If you're often some main method, you couldn't even super wouldn't even compile. So in a method that's been overridden, super.paint component refers, super.method refers to the overridden method. So we're calling it because it does something useful, namely it paints the background. Okay? Now, what's happening here? Besides, it turns on anti-aliasing, which is misspelled there. I don't care what anti-aliasing is, except that it makes it look a little nicer. But yeah.
I'm not sure this counts polymorphism, but we take the graphics object G and we treat it as a graphics 2D object.
Okay. So yeah, this is called a cast. And what we're saying, so G is a graphics object. So originally in Java there were just graphics objects. And then I imagine people realized that there just weren't enough methods available on graphics objects to do the kinds of things people want to do. So they created a new class called graphics 2D that provides more functionality. But they had already defined all all these classes that use graphics, and so they didn't change paint component to take a graphics 2D object. They just left it the same. So this method here, set rendering hint, isn't available on a graphics object. So it looks like what we're doing here is we're turning G, which is a graphics object, into a more powerful graphics 2D object, so we call a method on it. But that's not really what's happening. We're not changing anything. What is the relationship? Given that I'm doing this cast, what's the relationship, you think, between graphics 2D and graphics, those two classes, which are both library classes? Given that you can cast a graphics object into a graphics 2D object. Yeah?
I'd imagine the graphics 2D object is a subclass of graphics.
Right, graphics 2D is a subclass of graphics. So if you went and looked at the code, it would say graphics 2D extends graphics and adds a bunch of methods. That means it's possible that this cast will succeed. Okay? There's no guarantee. Imagine there's some other graphics, it may be that G is just a graphics object and it can't cast it to a graphics 2D, in which case I'd get an exception here. So why am I so confident that this isn't going to crash? If someone passed a graphics 2D object to this thing, that's always legal. And in that case, it's safe to cast it to treat it like it's a graphics 2D object, because it really is. So might this crash someday? Yep.
Well, as the programmer, we have a certain degree of control over what objects will get passed into that method. If we just know our implementation of this method will never have an invalid object.
Yeah, except we're not the people that are calling paint component. Paint component is called automatically by other swing classes somewhere. So I just know, I just have inside knowledge. I just know that in swing nowadays, it always passes a graphic 2D object to paint component. It's always safe to do the cast. I just happen to know that. Now, Suppose I was not certain about that. I wanted to turn on anti-aliasing if it were available. Okay? How could I check and see if this graphics object I was given is also a graphics 2D object? Yeah?
Isn't there a method that'll just return the class?
Well, yeah, but we don't need to use that. I got another way. Yeah? Right, I ask if G is an instance of graphics 2D. Okay. You're basically asking, will the cast succeed when you do that? I just left that out because I know it'll always succeed. I just know this fact about the swing classes. Yeah?
Could we also use a try-catch?
Yeah, we could also use a try-catch. Yeah. You could catch the class cast exception, which is thrown when something doesn't cast. So, now, if this were graphics 2D, we wouldn't have to worry about it. But they, for whatever reason, they didn't change the header pane component. So I'm going to put this back. I'll leave it there. The thing to realize, though, is cast just changes your point of view. It doesn't change anything about the object. It just says, it just checks to make sure that this graphics, in this case, it checks to make sure the graphics object really is also a graphics 2D object. It doesn't change anything. It just lets you start treating it as something different. Okay? So the way paint component works is it paints all the ovals, it paints all the rectangles, it paints all the lines. These are the methods we had to override in order to be a mouse listener. Or this is probably, some of this is probably mouse motion listener. Some of it is, some of it isn't. I'm not sure which methods are which. But anyway, we had to override all the methods. We don't care what happens when the mouse exits, the mouse enters, the mouse is clicked. We do care what happens when the mouse is pressed. So whenever the mouse is pressed, we create an oval that's centered at wherever the mouse was when the event was created, or a rectangle or a line. And then we ask for a repaint. So that's where the ovals are placed, right? Or the shapes are placed. We create the oval, we add it to the list, and then we request a repaint. And what repaint does is, sometime in the future, when Swing feels like it, it calls repaint. And one thing repaint will do is call paint component. That's when things get drawn. Okay, and then I think the rest of the methods down here, well, the rest of these methods that we've overridden are empty. We do have get color, which looks at the radio buttons and decides what color is selected. And then down here we have an oval class. You know, an oval has a center, a radius, a color, and then it has methods to paint it, create and paint. We have rectangle, which has a center, color, width, and height, as a constructor, and a method that knows how to paint, and same thing for line. So there's our program. So, are there any questions about this program so far? We're going to change it, but yeah?
Is it possible that we could just make like a shape interface and then have our those C classes extend that? So instead of having 3 arrays, you could just have one shape array?
Okay, so I was going to ask for suggestions, and he just made one. So here we have 3 instance variables, one that holds the ovals, one that holds the rectangles, one that holds the lines. It'd be more convenient if we just had one array that held all 3 types of things. Okay? Now, the problem is, what type do, oval, rectangle, and line all have a super type in common? They all extend the same class. Who knows what that class is? Yeah?
Shape class?
Nope. No, in fact, let's look. It's not shape class, at least not yet. Look at the class here. Here's oval. What class does it extend? Yeah?
Object?
Object. So every class, if it doesn't mention who it extends the object class. And that's why every class, that's where it inherits the equals method from, among other things. So since all these oval, rectangle, and line have an object class in common, we could come up here and create an array list of objects. So we could do something like this. We could say private array list of object. We'll call that shapes. And then get rid of these guys here and put every oval, every rectangle, and every line we create into that list. You could, yeah?
Wouldn't you be limited to only the methods that object has?
Say that again.
Wouldn't you be limited to only the methods that object provides?
Okay, so the problem is he's right. We could put, so down here where we're putting things, right here we just have to create the one array list of objects. Down here, not there. Right here, when we create an oval, we put it in the shapes array. That would be fine. We could put ovals, rectangles, lines, anything we wanted to into that array list. The problem would come when we iterated over them right here. So we need to iterate over the shapes, pull things out of the shapes array list, but we wouldn't be able to call paint on them. What would be the problem? In fact, let's write that code here. Let's suppose we're going to get rid of these 3 separate loops and put in one right here we would iterate over everything in the shapes. But there's a red line under that paint. What's the problem?
Objects don't have a paint method?
Right, objects don't have a paint method. So we can certainly pull, everything we're pulling out is either an oval, a rectangle, or a shape. And we could pull them out. But we couldn't call a paint method on it because it's just a poor old object. Objects don't have paint methods. Now if we insisted on following this route, and again, the idea is to get rid of these 3 separate lists and just have the one, what would we have to do here? What would it give? We pull an object out, what would we have to do in order to paint it? Yeah?
Cast it?
You'd have to cast it. So you'd do something like this. You say if we know it's either an oval or a rectangle or a line, then we would say oval O dot paint. Okay, instance of. Okay, so we would say if it's an oval, then cast it to an oval and paint it. If it's a rectangle, cast it to a rectangle and paint it. If it's a line, cast it to a line and paint it. Otherwise, ignore it. We could do that. And then get rid of all these things. But there's a better way to do it. He suggested the better way. So I'm going to undo this so that it's going to be, I'll leave it for now. I'll undo it later. He suggested using an interface. So let's go now to...
You want to comment out the error?
Well, I'm going to go to a new place now. So I'm going to go to here, to Paint Panel 4. And what I'm going to do is I'm going to create an interface called Shape. So I'm going to have, instead of having an array list of objects, which is too generic for our purposes, I want an array list of shapes. Down here, I just have to create one array list of shapes to hold all my shapes. When we paint, I have to, if I want to paint my shapes, I just iterate over them and paint each one. I don't have to do any casting. Any shape I can paint. So for this to work, what needs to be in the shape interface? Yeah?
A paint method.
Paint method. This paint method that we're calling had better be in the shape interface. Better be declared. That's what makes this call possible. So, this code is all the same. Well, actually this code's changed slightly. Before we created an oval, we would add it to the oval list. Now we can just add it to the shapes list. There's just the one list. Color is the same. Okay, here's our interface. Okay, we don't have to write any code. We just say that anything that claims to be a shape object had better provide a paint class, a paint method. That's just the minimum you have to have. So we declare the interface. That's what makes everything up above work. Then what do we do with this interface now that we've declared it? What makes it so you can store an oval object into a shape array? Yeah?
You have to make the oval implement shape.
Right. We say class oval implement shape. We say, and implement shape because there's a paint method. If we didn't have that paint method, then we couldn't call it a shape. Same thing for rectangle, implement shape. That means it had better provide a paint method. The paint method was there before. We didn't have to change much about these classes. We just basically had to say at the top that implement shape. Now, suppose we wanted to add a fourth kind of of shape, like a star or something. What do we have to change about our program? Yeah?
We just need to add a star class and make that also implement shape.
Okay, so we'd have class star implement shape. Then we would be able to store stars into that array list of shapes. We wouldn't have to change anything about that. Paint component wouldn't have to change at all, because it just iterates over the shapes and calls their paint method. We just have to change the user interface. So up here where it'd just be this code right here where we'd have to have another case for creating a star. But the bulk of the code would be unchanged. Okay. Well, let's try this out. And, if we've done everything correctly, it'll work just like it did before. You won't be able to tell the difference as the user. It's just changed internally. Actually, there's a really tiny thing that's going to be different. See if anyone's clever enough to figure out how it's going to look differently. Yeah?
Have a little button for a star, right?
Well, I'm not talking about, if we had a button for a star, it would look different. So what I mean is, how does this right here differ from Paint 3? Paint 3 had 3 separate lists. Paint 4 just has the one list. And yet there is something different that your eye can see. Maybe not your eye, but if you got closer, you can see it. Yeah?
Aren't they drawn in the order that you clicked it, not in the order of the lists?
Right. So when these things are drawn, every time you paint the component, it paints the whole thing white, and then it draws the shapes on top of it. The way the code is written now, each shape, each time the thing is redrawn, it's drawn in the order in which they were originally put onto the panel, which means that later things are overlapping newer things. So on this one, I forget which I added first. Looks like I added the green first, and the blue is on top of the green. The blue blocks the green at one point. With the old version, it didn't quite have that, because we had separate lists. It drew all the ovals first, and then all the rectangles. So, small difference, but other than that, it looks like that. Okay, let's think of a way that we could make this code more maintainable, simpler in some way. How could we, in fact, it's down here I want to look at. There's oval, there's rectangle, there's line. What could we do to sort of boil this down and simplify the code? What's a way we could have done things differently from the beginning? What do you notice about, here's the line class. Here's the rectangle class. Here is the oval class. Yeah?
They have kind of similar instance variable.
Okay. They have similar instance variables. They all have this constructor that takes an X, a Y, and a color. And they save it away in the instance variables. They have paint methods, although the paint methods differ. But all their paint methods start by setting a color. So what can we do? Yeah?
Would we instead add the present instance variables to the interface?
Okay, so he's suggesting putting the instance variables into the interface. That won't work because interfaces can't have instance variables. Yeah?
So maybe instead of an interface, maybe we should have used the superclass of shape.
Okay. Right. So another alternative, instead of using an interface called shape, let's create a class called shape. And what we'll put in the shape class are all the things that rectangles, ovals, and lines have in common. And then in the rectangle and line and oval classes, we just put what's different. So that's a common strategy in object-oriented programming, is having a base class that has the common information, and then you just put the deltas, the differences, down in the other classes. Yeah?
While we're on that, is there a specific situation where using an interface is better than using a superclass? Because it kind of sounds like a superclass. What was it used?
Yeah, well, there is a trade-off. So you can implement as many interfaces as you wish. So if you have a class, you can implement 100 interfaces. But you can only extend one class. So you want to choose that class wisely. You want to extend the class that it makes the most sense to extend, and then, then if you need other, more aspects of polymorphism, you have to do it through interfaces. There are languages, C++ is the prime example, that let you extend multiple classes, but what it means to do that gets really complicated to explain. And so it makes C++ kind of difficult in that situation. So Java only lets you extend one class. Okay, so what we're going to do is we're going to take this class, which is version 4, and we're going to go to version 5. We're going to replace the interface with a class. Okay, so let me just show you that. Here's Jpanel. Now let's see, does that look any different than before? No, I'm just telling you, shape is now a class instead of an interface. Yeah?
What happens if you extend more than one class? Does the compiler?
Yeah, compiler won't let you. Okay, so evidently, rectangle, oval, and line now extend the shape class as opposed to implementing the shape interface. So that didn't change. This little loop right here didn't change. We can still paint the shape objects. This didn't change. It did change, it didn't have to, I'm not sure why. I just took all these things and put it down below, but we still got the one list that we're adding to. Get color is the same. Okay, and then we have the shape class. So we got the shape class extends the oval class, then the oval class extends shape, rectangle extends shape, line extends shape. So let's take a break and we'll look at how those 4 classes relate to each other.
This makes a lot more sense having done the extend now.
Oh yeah, probably. Oh. Yes.
Okay. Okay, so what I want to do is look at what happens with the shape, the new shape class. Now, I'll just tell you, these classes are also simple, rectangle, line, oval, that it may seem like we're using a lot of mechanism to build simple classes, and that's right. But, it's a lot better to illustrate these ideas using simple mechanisms, simple classes than complicated ones. So let's just see what's going on. So what I'm saying is that shape, and in fact my comment, a class that implements what all shapes have in common. So I have a class shape, it has 3 instance variables, an X, a Y, and a color. So why did I choose to put X, Y, and color into shape, but not put things like radius or length? Yeah?
Because you don't want to be generic.
Right, I want it to be generic. I want it to be things that every shape class, everything that extends class is going to have in common. And I just looked at what the 3 existing classes provided. All of them had to have an XY. Sometimes it's the center. It's the center of the oval, it's the center of the square, or the rectangle. It's the one endpoint of the line. But there's an X and a Y and there's a color. They had that in common. The other things they had as instance variables are all different. So any shape object is going to have these 3 instance variables, which are private. We have a constructor. If you want to construct a shape, you provide X, Y, and C, X, Y, and color, and they're saved to the instance variables. I added a paint method, and I just made the paint method do what all the paint methods had in common. The only thing they had in common was they set the foreground color. So this paint method, if you called it, it wouldn't do anything visible. It would just change the color that's used in that graphics object. Okay? Why did I add these methods? Why do I have get X and get Y? Yeah?
Because X and Y are private?
Right. X and Y are private, so I needed getters for them. Who's going to need to call these methods, the get X and the get Y? Yeah?
The paint methods.
Right, the paint method's lower down in the extended classes. So we need to provide a way for them to get the X and Y out. Okay? So that's what all shapes have in common. Right? It's just a plain old class. It extends object by default. It doesn't extend anything else. And it just looks like a regular class, but it's designed to be extended. So here we have oval. Let's see how it works. It extends shape. Now, why does it have to have instance variables? Because shape has instance variables. Yeah?
It has some properties that none of the other shapes have.
Right. Oval has some aspects that other shapes don't have. In particular, it has a radius. Since it's an oval in general, it has a radius in the x direction, a radius in the y direction. So we need to store that in the object. And then we have a constructor that takes in, now this is interesting, it takes in x, y, and color, and it sets radius x and radius y to 100 because we haven't put in the code yet that lets the user pick the radii. What's happening in this constructor? Yeah?
Well, it's calling the superclass's constructor for those three.
Okay. So what happens is when the oval constructor is called, first thing it needs to do, it needs to call the base class constructor, the superclass constructor, in order to initialize the instance variables that we just saw up there in the shape class. So this calls the shape constructor, and then we finish up by initializing our two instance variables. Now, that can be kind of confusing, so I want to draw a picture for you what's going on here. Okay, when you say something like this, you say, give me a new oval, and its center is at like 5, 5, and its color is red. The new part creates an object. It creates a space in memory to hold the object, and then the constructor fills out the spots. So when we construct this in memory, what instance variables are going to be contained by the oval object when we say new oval? Yeah?
There's the X, the Y.
Okay, he said there's the X, the Y, the color. What else? Yeah?
The radius.
Radius X and radius Y. So here's the trick. Even though we're saying give me a new oval, not new shape. I'm not saying new shape. And oval only has two instance variables listed. What you get is room to store the instance variables of oval. So you get room to store radius y and room to store radius x. But you also get room to store color x and y. So even though we said new oval, and an oval just has these two instance variables, we get room to store those instance variables as well. And the constructor needs to initialize them all. Now, would the oval constructor be able to store something directly into y or x or color? No, because they're private. They're private to the shape class. So we call the shape constructor. The shape constructor takes care of these instance variables. And the oval constructor takes care of these instance variables. The net result being that all the instance variables get initialized. Yeah?
So the only reason that you get those is because you called the super on the
Right.
constructor. Without that, you would only just get the methods from shape.
Right. If we don't call super, then there's no way these variables could ever be initialized. But here's the thing. You must call super. Okay? The first thing, if you extend another class, the first thing you have to do is call super. You have to give those base class variables a way to get initialized. Now, if you're really following along, you know that every class extends something, right? Every class at least extends object. So if the first thing you have to do in a constructor is call super for the object class, how come you've never had to do that all semester? Yeah? No, object's not an abstract class. It's a real one. Yeah?
It doesn't have any private variable that we
Well, it's true, object doesn't have any instance variables, but the fact remains, the first thing a constructor has to do is call super. Yeah?
Is it implicit?
It's implicit. If you don't put in the call to super, the compiler puts one in for you, and the one it puts in wants to call a zero parameter constructor. So if your base class has a zero argument constructor, which object does, you don't have to call it explicitly, it's just put in for you. But in our case, shape does not have a zero argument constructor, and if we left out that call to the super constructor, the compiler would complain. Yeah?
So what about like Jpanel? When you extend that, like what's your...
Okay, so we extended Jpanel, but we didn't call super on it, so Jpanel must have a... Yeah, Jpanel has a zero argument constructor, so it's automatically called for us. But it can be tricky to realize that an oval object contains instance variables. It has its own instance variables plus instance variables from the class it extended, and potentially instance variables of the class that extended, and so on all the way back to object. Yeah?
So if we forget to put in a super, like it won't warn us?
Yeah, it'll tell you that's a problem.
Oh.
Yeah. If you don't put one in and there is a zero argument constructor, it'll call it automatically without a warning.
Oh, okay.
So what we pictured right here is what the constructor is accomplishing. It's filling in all those instance variables, but it's got to make two constructor calls to do it. So back to here, you see that calls the shape constructor. It's operating, it's operating on this. There's some object here being constructed. The base class constructor runs on it, fills out 3 of the instance variables, and then we fill out the other 2. And if we left this out, it's going to complain. It says, implicit superconstructor shape with no parameters is undefined. Must explicitly invoke another constructor. So that's what that's all about. Okay. So when we construct an oval, it's x and y in color, and radius x and radius y are all going to be stored in the object. But these methods down here, like this paint method, cannot directly get at x, y, or color because they're private. So let's see what paint has to do. Paint, but as before, it calls super paint. And then before it said draw oval of x minus radius x, y minus radius y, 2 times radius x, 2 times radius y. Now we have to call get x and get y, those getters that are in the base class, in order to get x and y out. Okay. So we factored some of the responsibility for shapes up into the shape class, and all that's left down here is what's different about an oval. Rectangle looks the same way. It has a height and a width. It has a custom constructor that uses the base class constructor. It knows how to draw a rectangle. And it depends on the get x and get y method that it inherited, because that was public. The get x and get y are public. Same thing, shape. It has an index and ny. It overrides paint, but it makes use of the get x and get y methods that it inherited. Okay? So, let's see, that's paint panel 5. Let's see how that works. Okay. Still doesn't look any different from the user's point of view. We just refactored it a bit, just trying to show you how inheritance works.
Got a question, Jay?
Question, yeah.
So with your painting methods, is it bad programming practice to in your superclass of shape if you had just made the instance variables protected and then just directly call them instead of writing get methods?
Okay, so we haven't talked about protected so much. If you declare an instance variable or a method protected, that means it can't be accessed from outside the class except in a class that extends. So if we had made x and y protected in shape, they would be accessible down in rectangle, oval, and line, but nowhere else. And I hold that it's bad programming practice for instance variables to be anything except private. I won't exactly call it controversial, but other people feel different ways, I say. You'll find books that thinks it's fine. But I prefer not to look at it. Okay, Now, we are about, let me see if there are any other questions before we add one more, add something else to the program. Okay. Let me run the program. And I would like to be able to, you can't really see my finger, but push the button down and then drag the mouse and then release it to shape the oval. So I'd like to be able to click to place the center and then drag to, to place that to expand the oval out. I'd like to be able to do that with the rectangle line as well. So what do I need to change about this program to do it? Okay. Yeah.
Maybe some of the mouse motion listeners that we overrode before, we just left it blank. We could use some of those now.
Okay, so we're going to have to override another one of these mouse motion listeners. We've got the mouse pressed. That's when the center gets set. And then as we drag it, we need to know that the mouse is being dragged with the button down, so that we can change the oval as that happens. Now, and then when we finish dragging, well, as we're dragging, we're going to get the current x and y coordinates of the mouse. But what are we going to do with them? How can we use that to affect the shape of the oval? Yeah?
So in the parameters where you have the end x and end y, or you just right now it's fixed, and so you just want to make those new variables.
So if we go and look at paint panel, look at say the let's look at the oval class. Right now it takes, when you construct it, it gets the center and the color. So we can't pass the radii as parameters to the constructor because the object's constructed when we first press the mouse. As we drag the mouse, though, the object has to change. So what does that suggest? What are we going to have to add to these classes in order so it can change as the mouse is dragged? Yeah?
We're going to need to specify maybe an initial xy and a final xy.
Okay. But how's the interface to the class going to change? What method do we need to add to our classes? Yeah?
Some sort of transform method?
Okay, so he said a transform method. Something that says, okay, so when it's constructed, it's going to be using, we're going to change it so that when it's constructed, we're going to use 0 as radius x and 0 as radius y. So initially you have a 0 radius oval. As you drag, that's increasing. So we need a method to which you can pass the x and y of the current point that you're dragging. So I call that method set extent. He called it transform. So set extent is going to take those other two pieces of information and change the shape. So we need to add a set extent method. Does that method need to be added to the rectangle class, the shape class? What? Yeah?
To shape.
Yeah, it's something that every shape is going to have in common. So we're going to see that method in the shape class. But we'll see how in a second. So anyway, let's go now to Paint 6. And here, I'll show you what I mean. So I've got red and oval selected. I put the mouse down, and then as I drag, it's setting that radius and this radius. And when I let go, it's frozen. So if I create a rectangle, green, stick it here and drag, then it's doing that for me. Okay, let's see how I managed to do that. Look at Paint Panel again. Let's go down. Let's see where the mouse listener changed. So everything's the same. Mouse pressed is the same. Get color is the same. Oh, here's mouse drag. So as you drag the mouse, periodically a mouse drag event occurs. And when a mouse drag event occurs, it just tells you, that means you have pressed the mouse down, you're moving it with the button down, and it'll tell you where the mouse is right now. So you get the x and y coordinates out. What's happening with this line of code right here? Remember, I previously created, say, an oval and added it to my list. So what happens as I drag? What does that line of code accomplish? Yep.
Is it going to change the last shape in your array?
No, it doesn't change anything.
Or
No, it's not changing. What's it doing?
you'll get it. Or
Right. I'm getting a shape out of that list. In particular, which one am I getting out? The last one that was added. So that means that I push the mouse down, put an oval or a rectangle or a line into the shapes array, into the shapes list, but with a size of 0. And then as I drag the mouse, every time I get one of these mouse drag events, I go into that array list, I pull out the last shape I added, which is the one I'm modifying right now, and I call the set extent method on it. And then I call repaint. Why is that repaint important? Yeah?
Does that give it the appearance of it motion?
Right. If I didn't call the repaint, you wouldn't see that it animate as I drag. Right? In fact, it's easy to show. So if I comment that out and I run it, okay, I can push it down. Now I'm dragging my mouse, and then I'm going to let go, and you didn't see anything happen. Now if I iconify it, bring it back up. There it is. But it needed to be, before I was repainting every time I placed the oval, every time I placed the shape. But now I've got to repaint every time I change it. Okay. So that means that since I can call set extent on current, and current is a shape object, there better be a set extent method in the shape class. So let's see where it shows up. Okay, that's kind of a weird looking method. What does that method do when you call it?
Nothing.
Nothing. Right? So how does anything happen if the set extent method does nothing? Yeah?
In the subclasses, we're going to override.
Right. So the problem is, what should set extent do if all you know is you're dealing with a shape? You know, if the shape happens to be an oval, yeah, then you can set its radius. But we don't know what kind of shape we're dealing with. So this is a method that is designed it's there purely to be overridden. I don't know how to write it generically. I know how to write it specifically to particular kinds of shapes. And so I just put it here so that it can be overridden down below. Now, why is it important that it be here at all if it's just going to be overridden? Yeah?
So it can be shared between all the different shapes?
Right, it's important that it be here so that you can call set extent on any shape. If this weren't here, we wouldn't be able to call set extent up above. But it's there to be overridden. So, nothing else is, okay, look, notice I did one other thing. Just for the heck of it, I made get x and get y protected. So this is actually a common pattern. I want the instance variables to be private. But sometimes I have methods that are of interest only to the derived classes down below. So by making get x and get y protected, they can only be called from things that extend shape, which may or may not be a big deal, but I wanted to show you what protected looked like. Okay, so here we are down in oval. Now it has the radius x and radius y instance variables like before. When you create the oval, they're set to 0 instead of 100 like they were before. And every time set extent is called, we just set the radius x to be the difference between the center and the current x, and y the same way. We just changed radius x and radius y. So we've overridden set extent like we wanted to. We override set extent here to get the width and the height. We override here to get index and ny. So each of these does a different thing depending on what type of shape it is. Okay? So now we get the behavior. So focus on the change we made. We added a set extent method to the superclass, to the base class. And then we overrode it in each of the derived classes to do something specific to that class. It's a very common pattern. You provide a method that is intended to be overridden. Inheritance doesn't happen by accident. It's not like you say, oh, I feel like extending a class today. I'll extend one. Typically, you're extending a class that was designed to be extended. So when you're designing a class, you're designing aspects of it so the class can be used. you're also designing aspects of it so it can be extended, if you want it to be extendable. All right, so there's just one more example to look at, but I don't see if there are any questions here before I go on. You really need to be grasping this because the final project, the Asteroids program, is full of interfaces and extended classes. So, better to ask now than later. Yeah?
So when you're organizing a project like this, would you want to do everything in the same, I guess, like tab? Or would you want to split it up in different, like...
Yeah, if this were a real project, at this point I would take, this thing contains 4 classes. I would split them out to their own files. It's just easier to show when it's all in one tab. I can scroll back and forth. But yeah, it would make sense to have a shape, you know, rather than have a paint panel class that contains 4 classes, to have a separate file for each one. All right. Now, I think there's one thing that's kind of weird about this implementation. Maybe you won't agree. What's weird about the shape class? Yes?
You can't really call it by its, you can't like really call it by itself, or...
Well, you can create a shape object. We could create a new shape object, but it can't draw itself, right? I mean, you could create a shape object if you wish. It would have a center and a color. You could call the paint method on it, but it wouldn't do anything interesting. Nothing would show up. So it's kind of a, you know, it's there just so it can be extended. There's something else kind of weird about it. What's weird about this method right here? Well, it doesn't do anything. So here's the deal. This method is intended to be overridden. Anyone that extends this class had better override setExtend, or their class won't work. I would like to force anyone that extends this class to implement setExtend, rather than just putting it, you know, we could add to the documentation right here, this must be extended by any class, this must be replaced, this must be overridden by any class that extends shape. I would like to give the overrider no choice. Yeah?
We could make an interface with setExtend in that and have shape implement that.
Well, we could use some combination of interfaces, and yeah, we could use that combination of interfaces and a class. But I'm going to show you a different way to force someone to implement. So clearly, if setExtend were in an interface, then you're forced to implement it if you implement the interface. So what we're going to look at is an alternative. So here we are in the Paint 7. It won't look any different when you run it. Everything about the paint panel class is the same. Nothing's changed there. What we've done is we've declared the class abstract. So we have this method right here that's declared abstract. So if a method is abstract, if a class contains an abstract method, it must also be declared abstract. What do you suppose it means? First of all, notice right there, I'm not pretending that this is implemented, right? It's just a header. Abstract classes do not have implementations. They're just the header information. Okay? So what do you think is the practical result of declaring a method abstract? Yeah?
You force the person who uses the class that they have to implement it because you're just
right.
giving them...
If you extend the class, you must implement setExtend or declare yourself abstract as well. Okay? So this is a trick. I didn't have any good idea of how to implement setExtend. I expect anyone that extends the class to override setExtend, so I'm going to force them to do so by declaring the method abstract. So now if you try not to, if you don't override setExtend, you'll be told you have to. Now, when a class contains an abstract method, you must also declare that class abstract. And if a class is abstract, you cannot directly construct it. So it is illegal to do something like shape S equals new shape. If you try to do that anywhere, it'll tell you cannot instantiate the type shape because it's abstract. So what good is a class when you can't create a new one of it? Yeah?
If you tried to do the thing with like the array list of shapes, would it also throw that?
No. You can do, in fact, we do that up here. We create an array list of shapes. We're creating a new array list there, not a new shape. But nowhere can you write now new shape. So what's the deal? Why is this a good idea? Yeah.
So I mean, you have all the parts that are like, so for all the shapes like ovals and like rectangles and everything, lines will have like the same, like similar parameters, and you'll have like a couple methods that'll always be the same, like get x and get y. But just, you know, the set extent is going to be different for all of them. So you're going to have the similarities, but also.
Okay, so he's sort of describing, you know, what we've achieved by using inheritance. But doesn't it seem like a class that can't be, you can't construct a shape object by saying new shape? Yeah.
Well, it didn't matter if we could construct it before either because they couldn't be shown or do anything.
Right. We weren't doing new shapes in the first place. Our program doesn't depend on being able to create shape objects. I just finished arguing before that they're kind of useless by themselves. They're kind of useless until they're extended, and especially until that pink method is overridden. So what I did was I created a class called shape. It has everything that rectangles, lines, and ovals have in common. And it's not intended to be used directly. Its only purpose is to be extended. And so down here, I can extend shape. Then I have to override set extend. If I don't, I'll get an error message. I'm still allowed to call the base class constructor that way. I just can't say, I can say super, and that calls the shape constructor. I just can't say new shape anywhere in the program. So it's strictly there to be extended. There's a class in the asteroids program called participant. It's an abstract class. It is there purely to be extended. And if you want anything to be on the screen, an asteroid, a ship, an alien ship, a bullet, whatever, it has to be a participant. So when you go and add alien ships to your game, how are you going to do that? How are you going to create an alien ship class? Yeah? You'll have to extend participant. Participant is an abstract class. So participant will contain some methods that you must override. One of the methods that you must override, which makes sense, is there's a method that describes the shape of the participant. You know, so the ship is shaped sort of like the letter A. That's very different from the asteroid. So the method is sitting there. The abstract method that gets the shape of a participant is in the abstract class participant. You have to override it later. So this becomes important later on. Yeah?
So what is the difference then between an interface and an abstract class?
Okay, he's asked what's the difference between an interface and an abstract class? Well, interface has a name. It can't have a constructor. It can have no instance variables. It's just a list of methods. Now, we could create an abstract class that had no instance variables and no constructor and just a list of methods, method headers.
Abstract methods.
Yeah, they'd all be abstract. So you could have an abstract method with a bunch of abstract class with a bunch of abstract methods and nothing else. You could have an interface with the same name, same method headers.
Yeah, identical.
So what's the difference between the two in that case? Which would you prefer to use? An abstract class where all the methods are abstract, or an interface where all the methods are listed? Same method, same name.
Interface.
Why is the interface preferable? Yeah?
Because you can implement as many of them as you want.
Right. That's a case where, you know, they serve the same purpose in that case. An abstract class with no instance variables, no constructor, where every method is abstract, is effectively an interface. But if you extend that class, you've used up your one extension. Right? You can only extend one class. So if it's going to function as an interface, make it an interface, and then you're free to extend some other class. So the difference between an abstract class, except in this extreme example I just gave, between an abstract class and an interface, is an abstract class can give you some functionality. It can actually implement some methods. It can have a constructor and instance variables. It's just going to have some method in it called that's declared abstract that you're forced to override. So you could very accurately describe the abstract class shape as being, it's just describing and implementing all the aspects that rectangles, lines, and ovals have in common. Okay? Yeah?
How do we know super is calling shape and not something else?
Okay, how do we know that this super is calling a shape constructor and not some other constructor? How can you tell to which class super refers? Yeah?
Because the class oval extends shape.
Right, because it says extend shape right there. Now, if this weren't here, what would that super refer to? Object. And in fact, we get an error because object doesn't have a 3-parameter constructor that takes those particular parameters. So, yeah, that's how you do it. Any other questions? Yeah?
Well, and also, if you could just highlight it and cover over and actually mention it.
That's true. Let's go use Eclipse. Yeah, it says paint7.shape.shape. So it's telling us it's the shape constructor. Okay, now, let me tell you about the rest of the week. Tomorrow in lab, what you're going to do is take the starting point for the asteroid project and just kind of mess around with it. Not really doing things of much use toward implementing the game, but just experiment with it so you can learn your way around the classes. And then in lecture on Wednesday, I'll just do my presentation of the same code, of the starting point, answer questions that you might have, how to get going on it. So,
My class, same thing.
What's that?
I'll be doing the same thing.
And Stefan will have his homework session. Unfortunately, the homework's not technically due because of the late days until Tuesday. So basically, he'll be going over the asteroids project as well in his Tuesday afternoon session. So anyway, you got lots of chances to get your questions.
Yeah, I'll be 6:20.